Welcome to our final tutorial on trigonometry. In this tutorial, we'll review how you can calculate the angles and lengths of non-right triangles. We might not always have right triangles. We focus on right triangles for the first two tutorials because they're obviously a way for us to simplify vectors into their horizontal and vertical components, which is useful for calculating forces and kinematics. But sometimes you don't have right triangles, and for those cases you have two options. You have the law of sines, or you have the law of cosines. It is important to note while these are the only options you have for non-right triangles, these two laws will apply to a right triangle as well. So the law of sines shows that you have a ratio between A and sine alpha is equal to the ratio of B and sine beta, which is equal to the ratio of C divided by sine gamma. So let's try this example out. Let's say we have our ABC non-right triangle here, and we know the length of side A and the angles of alpha and gamma. And I ask you to find the length of side B. What you might initially realize is that if we're applying the law of sines, in order to solve for B, we first must know the angle beta. And we can calculate that because we know that all of the interior angles in a triangle are going to be equal to 180 degrees. So to begin, let's solve for beta. We know that 180 degrees, let me get my pen out here, is equal to alpha plus beta plus gamma. If we rearrange this to solve for beta and plug in our known variables, we know that beta is equal to 180 minus 25 minus 125. Or that beta is equal to 30 degrees, which is equal to 0.52 radians. Now that we know what beta is, we can now use this law of sines equation, start here, to solve for the length of side B. And to simplify this math, let's go ahead and calculate what alpha would be in radians. So we know it's 25 degrees, and if you multiply that by pi radians over 180 degrees, you'll find that 25 degrees is equal to 0.44 radians. Now let's rearrange our law of sines equations here to solve for B, where B is equal to A sine beta over sine alpha. If we plug in our known variables here, we can show that B is equal to 10 sine of 0.52 over sine of 0.44. And if we plug in all our numbers here, we'll show that B is equal to 11.7 meters. As I mentioned, other than the law of sines, we also have the option of using the law of cosines. So if we take our non-right triangle ABC again, if we know the lengths of two sides, let's say A and B, and the angle between them, let's say the angle gamma, we can solve for the length of side C. And this applies to solving for any of the sides of this non-right triangle. As long as you know the length of two sides and the angle between those two sides, you can calculate the length of the third side of the triangle. You'll never be asked to memorize this equation. It'll be on your equation sheet, but you will need to know how to use it. So let's try the law of cosines out on a problem that's more realistic for biomechanical applications. So let's say you're working in a biomechanics lab and you're asked to study the landing kinematics of female volleyball players at risk of ACL injury. And let's say you're asked to find out how far the athlete's foot is from their hip joint during landing as a potential screening tool for reducing the risk of injury. Let's say you know from measuring the subject that the length of their thigh is 30 centimeters, the length of their shank is 26 centimeters, and that their knee angle here, theta, is equal to 150 degrees. If we know this information, we can go ahead and calculate the length of C, which is the distance between the foot and the hip joint. So let's use the law of cosine. To refresh your memory, that is c squared. In this case, it will be, excuse me, let me get my pen out here. C squared is equal to a squared plus b squared minus 2ab cosine theta. Or in this case, this will be equal to 30 squared plus 26 squared minus 2 times 30 times 26 times the cosine of 150 degrees, which we can calculate to radians. That's 150 degrees. And if we do that and plug in all our numbers here, we can show that the length between the hip joint and the foot during landing is 54.1 centimeters. So to review, the learning objectives of these tutorials were to review trigonometry concepts you learned in prerequisite courses. And we talked about Pythagorean's theorem, we talked about the sine, cosine, tangent functions, as well as their inverse functions for solving the lengths and angles of right triangles. And finally we talked about the law of sines and cosines in terms of solving the lengths and angles of non-right triangles. I hope that this refreshed your memory a little bit of how to use these trigonometry properties, as it will be a vital part of this course. We also showed how we could apply trigonometry to solve biomechanics problems, including solving for vertical and horizontal components, as well as solving for angles and lengths. The next steps are to log into Canvas and look under quizzes and complete the trigonometry quiz. I'm not grading these quizzes. You get unlimited attempts, and this is all it's going to do is count towards your participation grade. If you complete these by Monday, September 14th at 1 p.m. before class begins, you will get credit towards your participation grade on your final grade. If you have any additional questions, I highly encourage you to email me, visit me at office hours. If you can't make my office hours, try and set up an appointment with me to meet another time, because this will be a crucial part of your success on your first exam, your second exam, and your final exam in this course. I hope you enjoy these tutorials. If you have any feedback on how I can improve these tutorials in the future, please send me an email. Have a great rest of your weekend, and I'll see you in class on Monday.